So I'm going to have, I know a number of us are going to be covering some things. Hopefully you'll cover the same stuff. But I'm going to talk about a few highlights and some sidelights of the 2014 CES. Just go to the next one. So here's some highlights I had, and I'm a digital storage guy, and therefore I look for this kind of thing. Put another conference on, so some things from that. But there's some interesting things going on. There was actually a discussion yesterday, if you remember, about clouds, and one question was about personal clouds. There are a number of storage devices available from companies such as Seagate and Buffalo that have been announced, that, as well as Western Digital and several other companies that basically provide you with a network-attached storage device that you can access over the internet. So they're calling these things the new product category personal cloud. There also are, in Seagate and Buffalo have some products there that actually are wireless Wi-Fi devices that have up to 10 hour of functional battery life. So it's a very interesting category of products in the world. In addition, there's some interesting things they're developing that I think will have important ramifications in the basic architecture of computers. And that is with regard to the development of non-volatile memories. Okay. In particular, there is a DIMM product that was announced by SanDisk and Diallo Technologies that basically, and I'll show a picture of that in just a minute here, that would allow you to use flash memory as part of a computer's memory architecture with a very fast bus that you can have, the computer bus itself. So it's even faster than the PCIe bus. Now, in the future, we're probably going to see products that have speeds that are approaching those of traditional DRAMs, which might include MRAM or possibly resistive RAMs in the future. Also, faster connections, because you have faster storage devices and more richer content for our 4K products and that sort of thing, even with HEVC coding. We're still going to need faster database, especially working with the raw original content. And so, for instance, the Mac Pro has been introduced with the 20 gigabit per second Thunderbolt 2 interface, which is basically a PCI-based interface. It's a direct attached storage device. The other thing I saw at the show, and anybody who's around there probably saw this, is there's giving you more and more objects that can capture content. Of course, we all have our phones that have cameras on them. We all have our tablets, that sort of thing. But there's a lot of individual little tablets. The GoPro was one, but there must be about 100 other companies out there that have one sort of camera product or another, that they were showing. In addition to recording this, recording that, like recording stuff in your car. So you basically have your own way of saying what actually happened during the accident. So, in addition to this, there's other new ways in which people are using some of this connectivity. One example was this Bluetooth pen, which you can actually write. When you write, this thing will record that information into your tablet or your mobile device in the application. So, interesting things that are out there. Let's go to that. So, some stuff. These things here in particular were from Seagate. Seagate bought, let's say, a French storage company a while back. Up in the upper left-hand side, there's a roly-poly USB things. You push it down, they won't stay down. Just below that is a 1 terabyte silver-plated sphere, which is also from there. And to the right of that is this product. This is a 5 millimeter thick, 500 gigabyte hard drive that's made for use in a tablet computer. In fact, I saw there was a press release the last few days that actually tablet computers with 500 gigabyte storage capacity use these drives. So I'm calling those fat tablets. Let's go to the next one. Over the upper left hand here is this ultra dim product I was talking about. So this basically is putting flash memory right on the DIMM. It was a DIMM card added and allowing you to access that memory, non-volatile memory, directly over the computer bus. As I say, there's also work going on. Things are showing up with new storage technologies such as MRAM and such, which can go at speeds that are approaching those traditional dynamic RAM. In the lower left here is something interesting. There's a lot of OLED things out there. This particular device was an LG phone with a curved display. And you're supposed to be able to actually, from about this kind of curvature, you can flatten it out. But apparently the idea there is that, for instance, I can get a more immersive experience in video watching that display. On the right hand here I think it was like 160 high-resolution DSLR cameras that were capturing a person from every possible angle. Instead of the Sony, but it was another outfit doing that. And they created this model of this person over here on the right-hand side. You can actually take your finger and you can spin that person around with very high resolution display, spin them whichever axis you want to. And the idea behind this is they're actually trying to make higher resolution avatars, for instance, for games or for renderings of various sorts, for production type purposes, professional production purposes. In addition, in the 3D printing areas, there is actually a place there where you can get your face 3D modeled and then get that put on some chess pieces or whatever other thing you want to make in your 3D printer. Let's go to the next one. So we mentioned some highlights, and I showed a few of those. So here's what I call some sidelights. So this sounds like an interesting technology. This is a technology that there was a booth that was advertised to be able to charge a bike, but it was talking about using dark energy as the energy source for this. So I'm looking forward to hearing more from this in the future, especially, let's go to the next slide. If we can use the way forward machine, the DeLorean with the flux capacitor, it's supposed to be flux capacitor, excuse me, and Mr. Fusion on it. So I think that's my last one. Let's see. Oh, no, it's not. But of course, the CES is full of imaginative and intriguing devices such as this robotic grill cleaner for cleaning your barbecue grill. So that's it for me for some highlights and some sidelights from the CES. Thank you.
Thank you.
I was reminded that I was supposed to do one more now here, and I will do that. Yes, so we have a workshop at 5 p.m. today, and this is a very important thing. It's room N258, and what this is about is the first established and passed standard from the IEEE Consumer Electronics Society. It is the standard on the IEEE 1874, a standard for documentation schema for repair and assembly of electronic devices. This will be an overview session to discuss it, but I think it also could be a good forum for talking about future IEEE standards that we might look at in the Consumer Electronics Society. This particular standard is important to being creating open manuals for being able to repair any electronic product. And I think it's an important step towards creating sustainable electronics in the sense of not just making things we end up throwing away. We can repurpose them, we can make them useful in places where people don't have as much money as in the more developed areas, for instance. So that's at 5 p.m. It's in room N258, and I hope some of you might come and join us there. Thank you.
Okay, thank you, Tom. So moving along, we have Stefan Moser, who will continue our tour guide to the CES show floor here. I think it's called.
Wireless power. I'm one of the innovation judges for the CES, and most of what I was judging was wireless chargers. It's a really big thing compared to the year before. There's heaps and heaps of units out on display. What I really think about them is that first of all, there was a lot of manufacturers out there on display, but also the wireless power consulting as well. They showed a few solutions or chips. What we can see in the first photo there is what it looks like inside, all the coils that have to be put in the interface stuff, but it's not really big. And I think really why we're interested in is it's convenient. It's not energy efficient, but it's extremely convenient. How many of you are carrying more than one charger right now with you? Right? You see your hands coming up. Every time you get a new device, you can see the manufacturer off and you have to go and get another charger. So when you end up with mobile devices, you're carrying 4 or 5 devices, you're carrying 4 or 5 chargers or more. Right? So you have a lot of accessories. With these wireless power chargers, you just throw a mat somewhere, plug it in, and throw your device on the top of it. And it's really fun, you don't have to carry that stuff around. The mat can be quite small too, so form factor-wise, it's also quite an elegant solution. So I think this is really what's going to happen in the future. Having said that, a lot of the manufacturers say these things are 97% efficient. What they don't tell you is how to measure the 97%. because they're not really 97% efficient. But the wireless consortium, their definition of it is, it starts after the first power conversion. We all know that when you switch from power supply to converting voltages down, that's about 30 to 40% loss. It's not a very efficient system. And if you look at that, typically we have about 3 or 4 conversion stages in those systems, and they're not called tightly coupled systems or loosely coupled systems. When you have a loosely coupled system, there's a lot of flux that escapes, so obviously the efficiency is going down. But I think despite the efficiency while looking at green technology, it's the convenience of this that's going to make a success. So that's one of the technologies we're looking at. We've seen the net and so on. The second one is, I thought looking around, that really struck me this year was, I was going to talk about TV, and I said, no, I'll talk about something different. And that's the automotive industry. We've had cars in the automotive entertainment side for many years. You know, and the main attraction there was the beautiful ladies, not the cars. But this year it's sort of changed. There's no beautiful ladies next to the cars. There's a bunch of cars there. And what to focus on is the processing power. You know, Intel would have some cars next to the BMWs and so on. And what's really changing is the features in the car. And there's a cartoon there where the guy tries to attempt to fix it, and that's going to be a problem, I believe, because most of the technology is so advanced and the networking in the cars is so advanced that the average automotive technician's got a real problem with fixing or repairing the faults in cars. But apart from energy management and new lighting systems and so on, one of the big features of it is the user interface. Right? There's no more difficult parking. You can get out of your car, the car parks itself. You can park 2 cars next to each other with a few inches, which you can't do with a manual car when you're driving yourself. So they have to go parallel, just go reverse backwards in the curb, and you get better space efficiency, more security, more safety in the cars, much more friendly user interface, apart from technical features, controlling the fuel injection systems, the braking systems, the oil systems. We're even looking at the air pressure in cars and telling you to go fill up the tires, and probably soon we'll be changing the air pressure as we go to suit the road conditions. So there's a tremendous change in the world is really changing. It was about 3 years ago we were at Braunschweig at a conference in Germany, and VW sent their chief engineer, and he told us he's the first chief engineer in the automotive industry who's an electronics engineer, not a mechanical engineer. So now the perspective of the automotive industry is changing from mechanics to electronics. So it's going to be interesting to see how this develops. Thank you.
Thank you, Stefan. Next up, we have Rich Doherty. He's going to take us through a particular personal walkthrough of the show floor.
Good afternoon. Great turnout, and of course, at least 1 or 2 products I'm going to repeat, but I'll have a different photo with you for you at least. I start out with the Toyota hydrogen concept car, really representing all the progress toward autonomous vehicles. I think many of us here know, and we're seeing in the sessions, that autonomous vehicles, vehicle replacement cycles are a tremendous draw for our talents in the social networking, power management, faster networks in cars now than we had in the best offices and labs a few years ago. And Toyota just showed this car here. It's due to be delivered in California in the next 18 months. And of course, the whole hydrogen economy going straight from hydrogen to a fuel cell to an auxiliary battery. We'll have to see if this works, but putting a lot of energy behind it. Next year. Thank you. Communications. Dish Network is the second largest satellite supplier in North America. And they have introduced a set of technologies to keep expanding their main system, a digital satellite receiver with 3 tuners that can get 6 programs at the same time. Now they've introduced wireless and auxiliary tuners that all work over a multi-network or Ethernet network, or both. So they're streaming hundreds of megabits around the household routinely, and these are consumer products that are released for a few tens of dollars a month. Once again, another view of the Toyota car. It was not running here at the show, but the Toyota commitment to it as one of the world's largest automakers and electronics users is significant. And we'll be following that and see how it affects other electric cars. Next. Switching gears a bit, I think we all know that AMD in the past has been known as a company that chases Intel architecture, but thanks in part to their design wins with the PlayStation 4 and the new Xbox One from Microsoft, they've introduced the Cavari APU. Now, what's an APU? It's a combination of a CPU and a graphics processing unit on the same die, sharing the same video memory. We're not talking bus speeds and other things, they're on the same die. So they've introduced this new Cavari CPU that will be for other uses, and I'm sure they will not all be in PCs. Just their first two wins with PlayStation and Xbox show that this is the direction of the highest performance graphics that anyone's developed to date. Next. Making graphics personal, Panasonic introduced a 4K wearable camcorder. This is the imaging side of it. It's designed today initially not just for consumers, but also for professionals, for teaching service procedures, as Tom mentioned with the new IEEE standard for comparable devices. We're getting to be more like watchmakers than we are solder and breadboard engineers. And this cable feeds to a small, I'll say a little larger than cigarette pack size recorder, which also has wireless capabilities. It will be shipping in 2014, and there's an HD version of it right now. Stu? Again with Panasonic, these are curved OLED screens that were forming a ribbon throughout their booth. And while there's been no product announced yet, these are beyond the prototype stage, so it'll be an exciting 2014, and we won't just be talking about Samsung, Sony, and LG, as those main drivers of technology. Next. I tried to avoid it, but Sony has a lot of innovations in their booth. If you had time to get back there, I know some of you were caught up in travel and couldn't. This is their 4K reference monitor, which they boast as having the greatest color fidelity, the most true dynamic range, and of course, 4K resolution. This is a very premium consumer product, or it's one that we'll see quite a bit of business and institutional use as well. And Stu? Staying with 4K, now this show saw for the first time 5K displays. So we have 5K displays that are ultra-wide, UHD if you will, 5,000 pixels, like 2160. These are 21.9 form factor. And Sony, LG, Samsung, pictured here, Toshiba, and others all showed 5K ultra-wide glass. Stu? It's a little bigger than the Panasonic product, it has a lot more features. Sony introduced a 4K consumer or prosumer camcorder that they're promising to deliver this winter for under $2,000. For under $2,000. This could significantly change the amount of content that's available, both for families, for business, for institutional use, and for Hollywood. Since more and more features are being shot with what were dubbed initially as consumer products. Stu? Not to be outdone in video alone, Sony has been the largest proponent of high-resolution audio. There was a high-res audio exhibit space over the Venetian. I know a lot of us didn't have time to fully explore. But they are talking audio capabilities beyond the DVD audio and Super Audio CD formats from a few years ago. And a lot of artists are watching this because thanks to the storage things that Tom captured in his talk, thanks to tremendously affordable audio capture gear, it's now possible to do better than the studio best efforts of most of the last century. Stu? Now, unfortunately, I couldn't find a single camera of my 4 that could capture the detail of this, but Sony was showing a football game, a soccer game, in 8K resolution, and these prototype smart eyeglasses, which are used to project up a virtual reality, augmented experience for the game, orange letters, and things that follow your eye tracking. So if you're looking at the right side of the field, a certain player, it will pull up the stats. It will give you the information on that player without you having to navigate around the smartphone or anything else. And it was quite a popular exhibit. Next. Okay. Sony's introduced for production this spring a short throw 4K projector, which can be just 20 inches away from the screen and project a 147-inch 4K image. That's a staggering advance. They haven't announced whether it's using laser illumination or LED, but it's a staggering direction for all those here who've been working with display technology over the years. Stu? Now, you're looking at what might be a dining room lamp in most houses, but that dining room lamp contains an HD or higher resolution projector, which projects down onto an ordinary table in a dining room, a playroom, a den, and it can project up anything you're calling for, and cameras in that projector sense what you're trying to manipulate. So it turns any horizontal surface into an interactive play, exploration, and workspace. And to repeat, a little different curvature here, so you can see from Tom's photo, the LG G2 Flex phone. Just amazing if you had time at the booth to see people of the larger group than myself standing on the phone not breaking. That general curvature does fit what we look for in a phone for our face and mouth, not a straight brick as traditional phones are. And of course, going into production, it opens up all kinds of possibilities for wearable, conformable consumer electronics. And last but not least, and this was very hard to see because it was only shown in a showcase over at the, which hotel? At the Wynn. This is a power brick. Going back to Stefan's other presentations, we have a Fin6 MIT engineered, very high frequency switcher, which replaces the 65 watt power brick beneath it with that form factor. Yeah. It's fantastic. Of course, it's 220 or 110 volt mains. They're working on DC to DC versions, but they use very high frequency electronics and cores. While they say the efficiency was quite 96%, they're in the 90s because they're just getting rid of the magnetic flux things that have been with our power supply designs for about 5 decades now. So that's a look at the CES as we had a chance to look at it, and look forward to the panel.
Okay. Continuing with our tour here, we have Sean Dubravic. Sorry, Sean, probably butchering your name. He is a special guest. He's joining us from the Consumer Electronics Association. I'm going to let him give his title as he gives before he starts his presentation.
Thanks, Stu. I'm the Chief Economist and Director of Research for the Consumer Electronics Association. We're probably best known as the owners and producers of the small CES that just happened here right next door. So what I do every year at the end of CES is go through a huge suite of trends. This will be available online, so you can digest it all in the coming weeks as it finalizes. But let me just walk you through a couple of the broad trends that we see in some of the applications as it relates to that. I see 3 or 4 trends coming out of CES this year. One is what I refer to as mass customization. So to think about technology as we purchased it 5 or 6 years ago, you tended to all buy the same PC build, or we all bought the same mobile phone, and increasingly we're allowing end users to customize that experience, whether it's through something like apps, where you can essentially customize the experience you're getting, whether it's something like what Motorola did with their Motorola X, where you can actually customize the components and the colors and other feature sets, or whether it's something like, go ahead and flip to the next one, 3D printing, whether it's using a 3D printing pen, like the 3D doodler you see there, whether it's traditional 3D printers, which continue to get incrementally better each year. MakerBot showed up for the first time at CES 5 years ago, so this was their 5th show. They ended up at CES because they won a competition which CA hosted, and so we, as part of that prize package, gave them a small 10x10 booth in the back of South Hall, and they have built from there. The Replicator Z18 is a large form, really prosumer 3D printer, and for any of you who dabbled in 3D printing, you know, one of the big issues is the unevenness of the heat. And so this is actually a sealed 3D printer and temperature controlled 3D printer. So for those of you who've dabbled that, I know that I'm always going back after a 6-hour build and finding that I ended up with a lopsided print because of something that happened with the heat. CeraJet, and just flip back really quick and I'll just close on the other two. There's also CeraJet, which does ceramic printing. There's ChefJet, which prints in sugar. So we're customizing across a number of levels, right? You could imagine, and these are pretty inexpensive. That ChefJet's going to be about $5 grand. So you can imagine, not many years from now, when you go into a bakery, you can get customized designs and customized elements for whatever you're buying. We'll go to the next one. Wearables, and I'll start to or I just wanted to highlight for this audience just a couple of the wearables. I think we're moving into an interesting space where we're starting to digitize the physical space around us, and we're largely, of course, using sensors to do that. When technology moves from a scarcity to a surplus, we tend to waste that resource. So you can think back to the 60s and 70s where computing power was a scarce resource. We used it very sparingly. And then in 1981, Xerox introduced the Xerox Star, which was the first computer to provide a graphical user interface. We would have never wasted computing power on that graphical user interface prior to that time when we started to see companies experiment. Of course, in 1984, a couple years later, Apple launches the Macintosh, which provided that same kind of graphical user interface. So in this next one, you see Mimo, which essentially digitizes the physical space around the baby. You see the stripes across the onesie, which measure breathing. Built into the little turtle there is a microphone, so you can pick up noise. There's also a temperature sensor built in, so you can measure temperature, not so much the temperature of the baby, but the temperature it's wearing two cubes of clothing. And of course, a Bluetooth enabled chip so that it sends all that information to your mobile phone. So you can measure all of these things. So we talked a lot about in the past about geofencing. I think we're moving to a world of biofencing, where you'll start to set things based upon biometric sensors. You can imagine that we tie this not just to our smartphone, but to every single thing in our house. So if that breathing of the baby falls outside of a given range, we want the lights to come on, we want the fire alarms to go on, we want all the alarms in the house to set off to let us know that some metric has deviated. The accelerometer inside the turtle also tells you whether the baby's on its back or on its front, whether it's moving or whether it's asleep. So there's a number of things we're doing now to digitize that physical space. Next one. And then, of course, sensors, and I'll just roll through a couple of these examples pretty quickly. Go ahead to the next one, Stu. This is the panoramic camera ball. Again, as sensors go from expensive to inexpensive, we waste them, right? We deploy them widely onto devices. 2006, 2007, when we first started seeing things like accelerometers show up in consumer-facing applications. Prior to that, we were using it for things like deploying airbags, but there weren't a lot of applications that were consumer-facing. It was about $7 or more per axis of motion detection. Now, give or take, this audience probably knows this better, but it's in that 50-cent range. And so we start to use not just accelerometers, but we tie them with gyros and we get multiple degrees of motion detection. Same thing with cameras. Camera lenses and camera sensors go from expensive to less expensive. We put them on not just the front of our camera, front of our phone, but the back of our phone. We have multiple sensors in it. Here, you essentially have a ball with multiple cameras in it, so it takes literally a 360-degree photo. And then you can go in and you can rotate that around. So everything that used to be static and fixed becomes interactive. Even what is essentially a static photo then is something you can move around and look at every angle. The next one, Stu. This is a bracelet that has a light sensor in it which measures your exposure to the sun. It's tied to the app. It tells you whether you're in the sun too much. It's called the June bracelet by a company called Natimo, and it measures essentially your exposure to the sun, warning you if you're getting too much sunlight and are in the range where you might start to see some skin damage. It will encourage you to go inside or protect your skin. Electric toothbrush, which now connected to your smartphone. So we're starting to digitize these everyday things, right? And when we start to digitize them, we're essentially digitizing the data that was already there. We could have, in an analog way, written down how well we brushed our teeth and kept a log of that. But now we are digitizing it. And as we digitize it, we can start to use all that digital data in unique ways. So the dentist of the future may ask before your checkup for a download of your toothbrush data. So when they ask you, have you brushed your teeth, and you kind of grimace and you kind of lie about it, now they'll just look at the data and they'll say, you haven't been brushing your teeth, or perhaps more importantly, you haven't been flossing this tooth appropriately, or brushing this part of your mouth long enough. Next one. Mother is essentially, because Mother always knows best, a platform 4 sensors. So you can see the different sensors down there. They come in different formats, whether it's a temperature sensor or an accelerometer, and they have a series of different sensors. And that mother there is a sensor hub to then convey that information. And so you can start to put them in things like your pillows or your beds or strap them to your dog and start to measure all kinds of different things. So we're literally digitizing all of these individual objects. And I think as a result of this, you're going to see the internet change fundamentally. Today we have about 2 billion worldwide desktop or notebook computers installed among users. We have about 1.5 billion smartphones plus tablets. Smartphones in the 1.3 to 1.4 billion range, and then tablets in about the 200 million range. This year, 2014, or maybe into 2015, smartphones and tablets surpass desktops and notebooks as installed computer devices. And so we've already seen the impact that's had on the way we use the internet, going from a more utility, shared experience to a very personal experience. Well, now we're going to take it even further and add in 50 billion connected devices that are very discrete, often very siloed applications. Next one. This is the Mimo bottle warmer. So unlike the wearable onesie, which is in the market, this is just a prototype, but it keeps the bottle warm. But pulling the data off of the onesie will start to, it keeps the bottle cold, but pulling the data off the onesie will start to heat the bottle based upon historical patterns of eating. So it will note that when the baby tends to start to wake up, it will start to heat the bottle, so the bottle is heated and ready and warm right about the time the baby has historically wanted to eat. We don't just measure our steps now, we measure the steps of everything you can imagine. This is FitBark. For those who want to measure how much your pets have walked or different things that your dog does, you can measure that. And you can imagine all of that information starts to get fed into other services. So I think the next big push, once we have all of this digital data, is to create a system where we curate and we add context to all of this digital data. I always use the example of Netflix. Netflix today uses a series of algorithms to make movie recommendations based upon essentially historical viewing patterns and a little bit of demographic data. But what if it had access to my smartwatch, which measured my heart rate and measured my blood pressure and could essentially tell Netflix how stressed I am or how excited I am? What if it had access to my thermostat, which measured indoor temperature and outdoor temperature, and it had access to the camera on my TV so it knew how many people were in the room, whether it was 6 people or 2 people, whether they were sitting up or lying down. All of a sudden, those algorithms get much more robust. So we're starting to move into an age of algorithms with all this digital data. Next one. Okay, go ahead and we'll just look at a couple of these connected really quick. This is Catzilla, because some of us travel away from our pets. All of you are probably away from your pets. This allows you now to interact with your pet, video chat with your pet, and also release treats. So you can reward the dog with treats remotely, and the treat will be dispersed to the pet. LG launched their the LG Home Chat, which essentially allows you to text to your washers and dryers and other appliances. So, what was your only friend? Yes, if your only friends are your washer, your dryer, and your vacuum, text them and let them know that you're on your way home. I think we're in a continuum of how humans interact with computers. So if you step back and you think about how we originally interacted with computers, it was things like punch cards, and then we started to introduce keyboards. And over time, we've moved the way that we've interacted with computers from the way computers need us to talk to them to a more intuitive, natural way where humans feel comfortable. If you think back to Palm Pilot, when they introduced graffiti, it wasn't really a natural handwriting recognition platform, but it was a hybrid between what the computer needed and perhaps some type of hybrid handwriting format that the human felt natural using. It was still kind of a unique language, you had to learn it. But we're increasingly moving computers closer along that continuum to where humans naturally speak. Texting is perhaps one of those. Of course, motion control, and I haven't shown a lot of those examples, but by 11 months, babies worldwide know how to point. Pointing is a very natural, intuitive thing, and so when you want something, you tend to point. cameras, of course, are getting better, systems are getting better, so we're seeing that more natural, intuitive thing move in. Go ahead, and I think that might be, yeah, close out the, I think that's the last one, so you can go ahead and go to the next one. That's probably it. Thank you very much.
Okay. So could I ask the guys to come up here and, oops, not changing here. Have to do the one thing that Gary reset. So I actually have a, I can't get it up there. I don't know why, but that's all right. So we've got about 5 minutes left, and there is a wireless mic. Can somebody grab it? Okay. We have opportunity for just a few questions and comments from people. I actually had 12 slides of my own, but owing to the time, I'm going to skip them. Yeah, so Scott, I think you were up first. And I'll ask for, please, a brief question and comment briefly so we can finish someone on time. It's on. Let's go.
Okay. Really good presentation, guys. However, I have a strange question to ask. When is enough going to be enough? I mean, we've seen all over the show, there's lots of inane products. You're sort of looking at it going, that's just mad. When do you think enough is going to be enough? Like you say, information, we're being frivolous with power, with information, with internet bandwidth, etc. Just ask your views on that.
Anybody want to deal with it?
I think going back to steampunk, it was never enough. There will always be a faster, more convenient. Unfortunately, the marketplace decides, and we may not see them in the marketplace very long. But with a lot of the technologies and products here, I think we're going to see throughout the next few years of sales.
And it will change what is enough. So if you look at computing power, there was a big drive for a decade or multiple decades to push more computing power into devices. I would say in some areas we've moved away from that. So maybe we are seeing enough of computing power and processing power in certain devices, but we're pushing other elements, pushing other limits.
Tom, do you want to make a quick comment?
Oh, yes. I think we should be seeing technologies as being like fashion, right? And if you just think of some of the crazy things that people have worn, you realize that there is no limit to the imagination of things people want to do.
Okay. Bob, and please, quick
Yeah, a variation of what he does best. You talk about all these smart things, especially in the dystopian presentation began. But what about making people smarter and more capable rather than just smarter things that will do favors they want to do to us?
I think one of the things that Sean showed, peace of mind, gives you a lot more time to explore, learn, and enjoy things. If you're not worrying about a baby, you've got more time in the evening, whether you're near or far. The pets, I'm not that sure. And the washing machine and the hair dryer don't talk to each other, but we do.
But Columbia already supplies tools for that.
So, I mean, my take on that is, just as Richard pointed out, if my thermostat adjusts based upon where I am,
I understand the peace of mind, but there's all this technology to empower the user, enable us to use our imagination to do things, not just be relieved of having to think.
oh, I definitely think so. I look at kids today who are thinking in three-dimensional space, whether it's games like Minecraft, whether it's design for 3D printers, whether it's, there's a company called ZEP, which does motion tracking for sports. So now they're seeing their baseball swing or their tennis swing in three-dimensional space. We learned how to program in a very linear, flat way, whereas kids today are learning in three-dimensional space. So I think that they are going to come up with ideas that we can't even fathom.
Well, in things like 3D printing, there's a whole major movement in fact.
Yes.
So the imagination, the tools we have for particularly young people to learn how to do stuff and to make things relatively easy are just enormous, and they're only going to grow more interesting as time goes on.
And now it's to link everything together. It's very different than how most of us grew up with.
So we actually are out of time, but I did have a set of slides, and I'm not going to show them all, but I just want to mention two incredibly cool side-light products that I saw myself. For some reason, the center screen, I don't know why, you can see it on the edges. This is a video doorbell. It goes in place where your current doorbell is. It's powered by the 24 volts that's typically in the home. Has a battery. When you push the button on it, it sends a push message to your phone that allows you to answer the doorbell remotely, talk, and listen. It has an infrared vision on it, so it works in the evening, and it has motion detection, so even if someone doesn't push the doorbell, but they start messing around in front of your home and moving around, it places a call and let you know there's something going on there. It completely blew me away. Yeah. And here, I know I'm making the conference chair nervous here, but we're now at the end of the session. This is the other incredibly cool thing I saw that just really you wouldn't expect to be excited about by a light bulb. But this is an LED bulb with a built-in battery that gets charged from the standard Edison base, and when the power goes out, the lights stay on. But it's more than that. It has a sensor that looks back into the power line and looks for the impedance. So the same switch that turns the light on and off when the power's there will continue to turn it on and off even when the power's off in the home, because it senses it's an open circuit. Turns everything on. So anyhow, that concludes the session. This will be posted in higher quality tomorrow at the IEEE website. Session started 1 minute ago. Hope to see you all tonight at the party at 7 o'clock. We're adjourned.